Okay, today class we're going to recap what we've learned about trigonometry so far, and then we're going to use that to apply it to word problems in real life scenarios. So let's go through a couple problems to recall our trig skills. Okay, identify the ratio which represents sine of c. So remember our so, ka, toa. Okay, so sine is opposite over hypotenuse. So if we're looking at angle C, the opposite side is 7, and the hypotenuse is 13. So that's all we need to do there to represent that as a ratio. Come over here then, we want to find the length of a missing side, x. So let's label our sides. If we're referring to this angle, this side is the adjacent side. This side is across from our right angle, so this will be our hypotenuse. So according to SOHCAHTOA, we're going to use cosine. So cosine of our angle, 42 degrees, equals the adjacent side, 20, over the hypotenuse of x. So remember how we have our little trick. We can go through the algebra, but we have our little trick to solve for x. Basically, it's 20 over cosine of 42 degrees. So if we punch that in our calculators, and we have to remember to be in degree mode for these problems, because these are in degrees, not radians. Okay, if we solve that then, we get 26.9 for our side length. Okay, so that's an example of how to find a side length. This is an example of how to find a missing angle. We want to go and find angle G. So according to this angle, this is our opposite side, and this is our adjacent side. So remember, opposite over adjacent is tan. So we want to find tan of our angle G. Remember, I'm going to call that guy theta. That's our little Greek letter for an angle. Okay, so tan of theta equals 35 over 24. Now recall, to solve for theta, to get rid of tan, we have to take the tan inverse of both sides. That's what cancels it out. So then theta equals tan inverse of 35 over 24, which is approximately 55.6 degrees. Okay, so we use our inverse when we're finding missing angles. Okay? And then just a little relationship to special right triangles here. Okay, if we wanted to find the exact value, that's the key word there, of tan of 60. So calculators aside, we don't want to punch this into our calculator and get the decimal. We have to recall in a 30, 60, 90 triangle, the ratio of our side lengths are going to be 1, root 3, and 2. Okay, the 1 goes with the 30, the root 3 goes with the 60, and the 2 goes with the hypotenuse of the right angle. So if we want tan of 60, so we want tan of 60, which is opposite over adjacent. So the opposite side of the adjacent is root 3 over 1. So we can just say root 3. And that's done. Okay, down here, we have to do the relationship with our special right triangle, the 45, 45, 90 triangle. So recall, the ratios of our sides here are 1, 1, and root 2. Okay, so 45 degrees for cosine is going to be adjacent over hypotenuse. So it doesn't matter which one you pick. The adjacent side over the hypotenuse is 1 over root 2. But remember, we can't leave that radical there. So we have to rationalize by multiplying by root 2 over root 2. So this becomes root 2 over 2. And that will be our final answer there. Okay, so that's a recap of a little bit of special right triangles, finding sides using trig, and finding angles using trig. So if we now transition to word problems, okay, these are kind of new terms for us, but in our word problems we're going to talk about our angle of elevation or inclination, or our angle of depression. So the angle of elevation is the angle your line of sight makes with a horizontal line. So for example, this little boy, okay, the angle of elevation is basically his line of sight, which we're going to assume is a straight line, okay, to the top of whatever he's looking at. Okay? So when we talk about some of these examples, we'll see in a second, it's usually in our problems going to be the angle made with the ground. Okay? The angle of depression then is if this young lady up here is looking down. Her line of sight is also this horizontal line here. And when she looks down, this is the angle of depression. Now, if you think about this, think back to our parallel lines. Assume their line of sights are both these horizontal lines, so they're parallel lines. So these are alternate interior angles. So really, the angle of depression and angle of elevation are the same. Okay, so remember that as we go through these problems. Okay, so in these, I always like to draw pictures, and you all know I'm a wonderful artist, so let's set this up. Remember, when you set up a ladder, this is your ladder. A ladder is not going straight up against something or straight across the ground. Okay, so this is your ladder. It's resting against some building over here, and we're going to assume the building makes a right angle with the ground, hopefully. Okay, so it's at a point that's 63 feet above the ground. So the ladder's hitting a point 63 feet above the ground. So this is 63 feet. If the ladder makes a 47-degree angle with the ground, so that's our angle of elevation. So that's right here, 47 degrees. What is the length of the ladder? So remember, this is the ladder, so this is what we're searching for. So we're going to use our trig, our trig skills now to find that missing side length. So recall, this is the opposite side and this is the hypotenuse. So that's indicating that we're going to use sine. So sine of our angle of 47 degrees equals 63 over x. So remember to solve for x. And you get 63 divided by that sine of 47. Okay? So if we punch that in our calculator and solve, we get 86.1 feet for our ladder. Okay? Let's look at another example here. Okay? The Gateway Arch in St. Louis is 630 feet. So let's kind of draw our picture here. We're going to assume it's 630 feet at its highest point, so at the top of the arc. So this is 630 feet. A person is walking away from the arc until the angle of elevation to the top is 55 degrees. And I'm going to clarify this word should probably be a little more clear. We're going to assume it's 55 feet from the ground, not from her line of sight. Okay? So we want to know how far the arch is from the person. So this is kind of a little hard to draw, as in you're looking at the arch and the person walked away this way. So pretend your little person's over here. I can't really draw in 3D. So the angle from the ground is 55, and we want to know how far she is from the arc. Like I said, pretend this triangle's coming at you. So let's see. We have the opposite side, and we have the adjacent side. Okay? So tan of our angle of 55 degrees equals opposite over adjacent. So 630 over x. Okay, let's flip those to solve for x. Okay, punch that guy in your calculator, and you should get approximately 441.1 feet. Okay? So now that we've seen a couple examples, we're going to do an activity outside today. So our goal is to use our trig skills and an inclinometer. Now, we talked about inclinometers in the past, but just to refresh it yourselves, we're going to download, if we don't have it already, because I know some of you deleted it, the inclinometer app on our cell phones, which basically can measure angles, okay, to determine the height of something that would otherwise be difficult to measure. So here's a little drawing. Now this one, the inclinometer, is going to be from your eye level. Okay, so we're going to measure the angle of elevation to the top of some building using that inclinometer. Okay, we're going to measure how far we are from that. Once we have an angle and a side, we can use our trig skills to find that value. Key thing is we have to remember in the end that it's from our line of sight, so we're going to have to add on however high our eyes are from the ground to find the whole height of the building. Okay, so let's gather our materials and we'll head outside.